love the chase and the hunt, and I set the pace when I'm running. I always
Namaste friends. So today in the entire Python family it is chapter 57, and in NumPy we are in chapter 16. So we actually put a base for the Python, and then we also put a base for the NumPy. So now we are actually getting a lot more deeper. So today's lecture, which is like the 57 and chapter 16 of NumPy, talks about data distribution. So what is a data distribution? A data distribution is basically a list of all possible values and how often each of the value occurs. Okay, so all these things are usually used in statistics and data science. Okay, so the random model offers methods returns randomly generated data distribution. So these are like used usually in data science and statistics. So basically a data distribution is, now say suppose in a particular street there are some 3 pizza shops, okay, and everybody is actually selling cheese pizza, cheese pizza, cheese pizza. So we actually take that particular street, and then of all the things the highest seller is the cheese pizza in this particular time. So we also have other pizzas being sold. So by taking the entire distribution, we actually came to know what is the data distribution. So that is what the data distribution is, and this is how it is actually used in data science and statistics. A random distribution is basically a set of random numbers that follow a certain probability density function, which is called a PDF. In our younger days, we actually studied this in our math class, but I'm not sure about you, but it is called PDF. So PDF is a function that describes a continuous probability, that is, it includes all values in an array. We can generate random numbers based upon defined probabilities using choice function. We already saw that. The choice method allows us to specify the probability of each value. The probability is set by a number between 0 and 1, where 0 means the value will never occur and 1 means the value will always occur. So basically we would have actually seen something like this: 0 to 1 probability density function. 0 is never occurring, 1 is always occurring. Okay, so now if you want to actually have an example, okay, so this is the example. Now what we are actually doing is generate a 1D array containing 100 values, where each value has to be 3, 5, 7 or this thing. Okay, so we can actually take this. I think we already did this in our previous lectures. So and we're also setting in this values. So if we actually take this, we actually say a random choice between 3, 5, 7 and 7 and 9, and then we say the probability is this, and this is a size 100. When we actually say print of this, this is what it actually gives us. So what are we doing is, we are setting the probability value of 3 to be 0.1, 5 to be 0.3, 7 to be 0.6, and 9 to be 0. Okay, so this is what it is. All right, the sum of all probabilities should be 1. Okay, when you go from 0 to 1, the sum of everything should be 1. You can return arrays of any shape and any size by specifying the shape and the size parameter. All right, so let's actually see this, and let's actually take this. Okay, once again, let's actually take this. Let's actually do this. So from the NumPy we import random, we actually take this and we say it's a size of 3, 5, and then we actually print this. So 5 of 1, 2, 3, 4, 5, and then this is 3. All right, so this we already did, and all this probability. So if you actually see, like, probability is 0.4 and 6, which is 1. So this is what it is, and this is 3, 5, and that is what I've been telling you. So this actually concludes our data distribution. I trust you would have actually liked it. If you have any questions, kindly contact me. I'll actually try to explain to the best of my abilities. Like always, I would like to thank 2 persons. One is you for giving me a golden time, and the other is my wife Jayashree, following me to follow my passion. Till we see next time, take care, cheers, and thank you.